In this segment, we'll finish up the bottom part of herd animal, and we'll look at for each loops and a new design pattern. Now, as we've seen in prior segments, herd animals can be thought of as two groups. There are followers and there are leaders. Each follower is interested in its leader's movements and needs to be updated anytime the leader changes position. Leaders manage their followers by calling method leadFollowers to make them all take a step, and by calling handOffFollowers to give them all a new leader. Method leadFollowers iterates through the myFollowers list and calls leaderStep on each one. And the code for that is right here in leadFollowers, and you can look at the loop. Now, anytime a leader changes its position by some increment, for instance, adding VLC, it calls leadFollowers with the same increment that it changed its own position by. And here's the line and step method that does that, in fact, right here. And it passes the amount to add to each follower's location, which is the velocity step in this case. Now, leadFollowers, in turn, calls leaderStep, and leaderStep updates the loc of its mommy outer object. And then returning to the diagram, the leadFollowers calls the leaderStep, and that call or adjusts the loc on the herd animal to which the follower object belongs. Method handOffFollowers likewise iterates through myFollowers, but this one calls changeLeader on each one, passing a new leader, and changeLeader modifies the myLeader member of its outer object. And by the way, in the code, handOffFollowers also empties myFollowers via a clear call, so that this list here will go away when the subject in question the leader in question no longer wants to be leading people and has handed them off. The code over here has a loop through the followers, and there's the myFollowers.clear we were just mentioning, but is doing something new. Any collection that has an iterator type that can be obtained by a call of method iterator, like our myFollowers, for example, can use a special for loop syntax called a for each loop, and that's this new loop we're looking at here. Now, the compiler translates the for each construct here by calling myFollowers.iterator to get an iterator, and then running the iterator through the specified collection by repeatedly calling next, assigning the result of each next call to FLW, which is the loop variable. In other words, the for each loop here translates to the same logic as the loop in leadFollowers, but it's a whole lot easier to look at. So this loop here that I just replaced it with, create a follower, run an iterator through all its paces, take each next call and assign it into follower, can be rewritten like we had it originally, that way. By the way, with a non-generified collection, without the angle brackets, then the for each loop variable would have to be declared as an object. But if you use generics to specify a type for the collection, like we did for myFollowers, then you can declare a loop variable of that type, like FLW here. Now, we've now reviewed all of herd animals' leader and follower logic. Let's step back and look at the leader-follower arrangement, because it illustrates yet another gang of four design pattern. Each follower is interested in its leader's movements. We might even say it's observing its leader's actions. In a sense, each follower asks the leader to keep the follower updated by calling addFollower and getting itself added to the myFollowers list, passing a follower inner object with methods for the leader to call to update the follower. This pattern is called observer, and it appears often in object-oriented designs. Here are the principal ingredients. We have one or more objects, the observers, that need to be updated whenever another object, the subject, is changing its state. So in our particular example, the observers are the followers, and the subject is a leader, or each leader is one subject. Each subject, or leader, keeps a collection of observers, or followers, that are interested in it. And that's the My Followers list, of course, in our example here. And if an observer wants a subject to update it, it registers with the subject by calling a method on the subject. And that's add follower. In our example, it tacks on new follower object to the linked list. When it changes state, the subject notifies its observers by calling appropriate methods on them, like leader step and change leader. Now, our example shows one way to represent or to implement the observer pattern, but it's unusual in one respect, and there are other common variations as well. So 3 points to follow on to this. First, normally the observers are of a different class than the subject. An OO design for, say, a course enrollment system might have a student class that observes a course class and requests update when openings appear in the course. Our example has both subjects and observers in the same class, and both herd animals. It's still an observer pattern, but it's a bit unusual for subjects and observers to be from the same class. In our example, the observers register inner objects, followers, with the subject, and the inner objects are proxies or representatives of their mommy herd animal objects. This is a common approach, but we could also have simply made leader step and change leader into methods of herd animal. Instead of having a list of follower inner objects, we would make my followers be a list of the actual observer herd animals directly. Then we could dispense altogether with the follower inner class. Whether one registers observer objects directly with their subject, putting the herd animals straight into the list, or registers inner objects of the observers instead, is a judgment call, and you'll see both designs in practice. And then third, subjects often supply a method to unregister as well. Perhaps a drop follower would have been our name for it. We didn't need that in our example. We did a myFollowers.clear when a subject, leader, herd animal dropped all its observer followers, and that was as much as we needed. Now, probably the most common use of observer is in GUI code, where the subjects are objects that represent GUI elements, like windows or buttons or menus. Other objects wanting to know when events like a button press or a mouse movement or so forth happen in those GUI element subjects, the other objects are the observers then that register their interest with the relevant subjects and get updates when GUI events happen in those subjects. But the pattern can be used in a great many different contexts. Anytime you have one object whose changes need to be reflected in changes or actions by another object, it makes sense to make the second object an observer of the first object and have the first object keep track of a list of observers and update them.